So 9(1) is work, and work is force times distance. So work is done when a force acts on an object and the object moves in the direction of the force. And force is often done on something when it moves against the influence of an opposing force, often friction. The use of work involves a transfer of energy between something and its surroundings. Watch out for W meaning work or W meaning weight. Work only happens if the object moves. And so some examples over here are like a car slowing to a stop or getting faster, and then so that would be work, and then work would not be if the weight is just sitting there, like if you're just holding it, the teddy bear. And work is measured in units called joules, and 1 joule is 1 Newton times 1 meter. And work is directly related or directly proportional to force and distance. Power is work over time. Power is work over time. Power is measured in watts, and the equation of power is power equals work over time, or P equals W over T, or watt equals joule over second. And 1 horsepower equals 0.7 kilowatts. And power is inversely proportional to time and directly related to mechanical energy. When work is done on something, it gains the ability to do work on something else. It gains energy! Energy enables an object to do work. Energy is measured in joules and has many forms, including mechanical energy. Mechanical energy is energy due to the position of the movement of an object. And there are 2 types of mechanical energy, potential energy and kinetic energy. Potential energy is energy that is stored due to an object's position. It has the potential to do work. There are 3 kinds of potential energy, but we are focusing on gravitational potential energy. Gravitational potential energy is work required to elevate objects against Earth's gravity. The potential energy due to an elevated position. The equation is PE equals mgh, or mass times acceleration of gravity times height, or Fg, like the force of gravity, times d equals PE, or work. And then that's a picture of different ways of potential energy.
Kinetic energy. Kinetic energy is energy motion measured in joules. The formula is kinetic energy equals 1/2 mass times velocity squared. The kinetic energy of an object in motion is the same as the work needed to bring the object to its feet from rest, or the work the object is able to do when it's going to a position of rest. And then the formula is net force times distance equals kinetic energy. Since the speed is squared, and if the speed of an object is doubled, the kinetic energy of the object is quadrupled. To make the speed twice as large, 4 times the work needs to be done for an object moving twice as fast. 4 times as much needs to be work. 4 times as much work needs to be done to come to rest. And when energy changes, work is done. And the work energy theorem. Work energy theorem is the connection of work and energy. The work energy theorem says that energy changes when work is done. And the equation is work equals changing kinetic energy. In this equation, work is based on net force. And if an object is being pushed at constant speed, then the object is being pushed enough to overpower friction. Then the net force and net work are now both 0. But the work energy theorem, changing kinetic energy equals 0. The kinetic energy is not altered or changed. And example, so the work energy theorem also has to do with speed that is slowing down. And if more work is needed, if an object has more kinetic energy. If the kinetic energy is twice as large, then the work is twice as much. And then there's a few examples of where kinetic energy can be found in the different types of energy, like heat, sound, light, and electricity. So heat is sensed by random molecular motion. Molecules vibrate in rhythmic patterns as sound, and light energy comes from the motion of electrons inside atoms, and electric currents are made from electrons in motion. And then conservation of energy. The law of conservation of energy is the investigation of energy and the changes from one form into another. The law of conservation of energy says that energy cannot be created or destroyed. It can be transformed from one form to another, but the whole amount of energy does not change. And so this is a picture from the textbook. It says when released, potential energy will become the kinetic energy of the air. And like what to review for the exam. So there's like roll calls, the test, and others.
And then we have some practice problems. So this is from, I think this is the first question of the test. But which of the following statements is true according to the law of conservation of energy? And Julia? That's right. Yeah.
And this one was from like a classwork problem that we did. So if 0.2 kilogram apple falls from a tree and has a velocity of 10 meters per second, just before it hits the ground, and what's the kinetic energy? So I can. Should I just go to the next one?
Does anybody have a calculator?
I do. It's 1/2.
Can I use the calculator on my phone?
We can.
What's the formula?
1/2 and yeah.
I got 1, but I think I did it wrong.
Wait, no, is it 10?
10?
No.
Where's the
Point two.
Oh,
It's
wait.
2 times 10.
It's 1.
I was right. 25, I was
right. Was I right?
No,
Oh.
That's what I got.
Oh, I didn't square it, but that's still wrong.
Wait,
Sorry.
Oh, is that right? I think it.
Yeah,
Wait. Why?
So like.
Can you
Oh,
go back
yeah.
one?
Yeah.
Sorry, just to see what the other thing is.
So the velocity would be 10 meters per second just before it hits the ground.
Why is it negative?
because it's falling downwards.
But that
And then
doesn't
it's
really
the mass.
Change the answer to square.
So,
Well, yeah,
yeah.
because when you square the 10, what happens to the negative?
it disappears.
Anyway, see that? No.
And then this one is from a roll call that we had. Can I see? It's like the kinetic energy in there.
So the answer's 5 for number A. 11, if that's right.
So I have like all the answers on the next page. So
we just go to that?
and then there's
So many station points. You guys want to see so many.
Aw.
I
Very nice.